Hello, let's continue work on the rational expressions for example 7. Okay, let's look at this. Example 7 is we want to find the least common denominator. Let's take a look. So all you have to do is for this type of question, let's label this as your, let me see. Label this as the first one, and then that's the second one, okay? So all you have to do is we're going to factor each denominator. So for the first one, we're going to factor this, the denominator. Okay, by now you should know how to factor it. So let's factor this. That will be 5x. What's left over is x plus 3. Okay, then we're also going to factor the second denominator. So that will be x squared plus 6x plus 9. And factor this, we're going to get x plus 3. Alright, and then you're going to have x plus 3, which is the same as x plus 3 squared. Okay, so this is a square. Once we factor it, alright, this is basically this step, and we're just going to factor the numerators. Once we factor it, then we're going to look is, your least common denominator, actually just equal to, like right here, all the factor, okay? So we have 5 right here, we have x right there, then we look here, we have a repeating, we have x plus 3, okay? So we have x plus 3, just me highlight it. So they're same. So what you do in this case, anytime you have the same factor, you just take the higher power, alright? So here we have the power is 1, here we have power 2. So when you have this case, you're just going to take the higher power, which is x plus 3 squared. Then that you are done. Okay? Again, you factor them, or separately the denominator, you factor them, then we'll look if they have, it's nothing repeat. In this case, 5x, nothing repeat. X, there's no repeating. So we have 5x. But then you have a repeating, which they're same, which is to take the higher power. So that is how you find the least common denominator. Alright, let's look at example 8. Okay, example 8, we have adding rational expressions with different denominator. Right? So let me just move this example up a little bit, so that way I can make some room. Okay, let's work on this. So anytime you have to add or subtract, actually it's the same thing. The step 1, you must find the least common denominator. Okay, so in this case, let's just find the least common denominator on the right side. So we look at the denominator for the first expression. Okay, x squared plus x minus 2. So we have to factor this. If we factor this, we're going to get x plus 2, x minus 1. So we factor this. Then we look at the denominator for the second expression, that's x squared minus 1. We factor this, you're going to get x plus 1, x minus 1. Okay? Again, once you have this, you finish the factoring, right? So we finished the factor part, just like the previous example. So then you look, right? Then you're going to look, what's my LCD, the least common denominator. We're just going to have x plus 2, okay? Each one's distinct. And then x plus 2, also there's no repeating. Then I look at x minus 1, the power 1, x minus 1, power 1. So we just take one of them. That will be x minus 1. So that is your least common denominator. Okay, so that is how you find the least common denominator right there. That's the least common denominator. Okay, So once we know the least common denominator, what you do is, right, so because you're adding them, so we're going to write down, okay, so I'm just going to write down the steps. So we're still going to do the factor first, which we already factored it. We'll just copy it down. So we're going to have x plus 3 for the numerator, and then we have the denominator. Again, we already factored it out. We'll just copy it down. Once we have these, so we know the fact is the least common denominator is x plus 2, x plus 1, x minus 1. So I'm just going to write it down. So I have x plus 2, right, the original one. Also, we said we also have x plus 1. Okay, you compare this to your least common denominator, and then you should realize that, you know, something, you actually put x plus 1 right here. Okay, remember that x plus 1 is something extra. So we're going to highlight this part. X plus 1, x plus 1. That is, you know, if you multiply the denominator, you also have to multiply something the numerator, because in that way we don't change the color. Don't change the color. We do not change the value. All right, I'm just only thinking about this color is too dark. But anyway, let's just keep it that way. Okay. Then also, again here, the original one is x plus 1, x minus 1, and then because the LCD, we also have to multiply x plus 2, right? So multiply something numerator, you also have to multiply something the denominator. Okay, so let's change a different color. So let's do this color better. Okay, so you multiply the denominator x plus 2, so the numerator also have to multiply x plus 2. That way you don't change the value. Once we have this, okay, the rest should be really simple. Okay, because now you have the same denominator, so just make it a little bit prettier looking. X plus 2, x minus 1, and x plus 1. Okay, and then we're going to just add all the numerator together. So we'll just write it down. 2 times x plus 2. So once we have this, the rest you're just going to use the FOIL method to finish the rest and then collect the like terms. Okay? So let's go ahead and finish this up. So you're going to have x squared, and then you have x, and the plus is 3x and plus 3, and then that will be right here, 2x plus 4. Okay, so then it's over x plus 2, x minus 1, and x plus 2. So all you're doing is just simplify it. Okay, what you're doing is just simplify it. Now we just have to collect the like terms. Okay, so we have x squared, so we have 1x, 3x, and then 2x. That gives you plus 6x, then plus 7. Okay. Again, the denominator doesn't change, so we'll just write it down the denominator that way. So you find the common denominator, and then you add all the numerator together. So then you collect the like terms. Once you collect like terms, you need to look, okay? You need to check the numerator. Can you factor further? So in this case, can we factor more? Alright, if I can factor more, so I have to factor it and see if I can cancel anything. Okay? But in this case, we cannot factor anymore, because the 7 right here, you know, there's no way I can factor a x plus 2 or x minus 1 or x plus 1. So in this case, that will be your final answer. Okay, so that will be your final answer. So let's just write it down. We know the fact is that x cannot be 1, x cannot be -1, as it cannot be -2. Okay, so you can just go back and look right here, or the original question, doesn't matter. So you're going to have exactly the same thing. Alright, so that is the example, I believe that's example 7. Okay, let's go ahead and look at example 8. Oh, that was the example, actually 8. Okay, let's look at example 9. So example 9 is simplify a complex rational expression. Okay, you're going to use this type of question. I think if you're going to take a pre-cal or anything further, you're going to use a lot this kind of algebra to solve questions. Okay, let's look. Sometimes you see this question, you just immediately feel like, oh, that is so much, so inside a fraction looking to have another fraction is just making you scared. But if you look at this, it's really not that bad. Alright, anytime you see this, all you have to do is you're gonna have an x, you have an x. So your idea should be, alright, here is what you have to think in your head. You just want to get rid of this extra fraction. Okay, so all you have to do in this case, okay, you just have to multiply, let me just write it down. Alright, let me just write it down. All you have to do is just multiply x over x. Okay, because you see x right here, you see x right here, that both their numerator, or not numerator, both their denominator in, for the top, and then look at the bottom, is also is just a denominator. So all you have to just multiply x over x. Okay, because x over x just 1, you didn't change the value of the expression. Once you have this step, the rest is easy. You're just going to multiply, right? Distribution actually. Alright, if you think it separately, that maybe it's easier for you to see. So then we're just going to multiply 1 multiply x, it just gives you x. Right? 1 over x multiply x, if you get confused here, 1 over x multiply x, it just gives you 1. So here we're going to have plus 1. Right? Then now we look at the bottom right here. Right? So again, you're just going to use 1 multiply x, that will be x. That will be subtract 1 over x multiply x, again give you 1. Okay, so if you think of this way, and then look, there's nothing I can do from here. I cannot factor it, so that is your final answer. Look at how easy actually this is. Right? You have a fraction for your numerator, and then all you have to just multiply x over x. Okay, let me just highlight this part so maybe you can, go back, because all you're doing is you multiply x over x. So then you're done. So that is the question. So just be careful when you have this type of question. Alright? It's not that difficult. Okay, let's try example 10. Okay, where's my example 10? Let me find it. Okay, example 10, we have simplify, again complex number. This one looks more complex. Alright, let's see if we can do this. So here we are, this portion. Okay, so that is something you want to make it disappear, right? You want to make it disappear. So all you have to do is you just multiply those, treat it like a factor. So you multiply, multiply x times x plus h over x times x plus h, because I wanted it, to disappear. So let's see. Once we have this, the rest is just very, very easy process. It looks complicated, but it's really not that bad. Okay, so we do distribution, right? And then we do distribution right here. Same as the denominator, okay? So when I do this, if you want to do that on the side, you're going to have 1 times x plus h, right? Distribution multiply x times x plus h, right? Then what happens right here is this term is cancelled. We're going to have whatever left is only x left, right? And then you look at the second term, that will be minus 1 over x multiply, okay, that I'll do this on the side as well. 1 over x multiply x times x plus h. Then your x is gone. So what is left is x plus h. Remember, there's a parenthesis right there, okay? Because there's a subtract, be careful on that one. And then for the denominator, so we're going to have x plus h, and multiply h, right? You just multiply them. The ones we have here, we realize x minus x is just going to be 0. Then we're going to have negative h, the numerator, and then we have x times x plus h, and then multiply h. Then again, once you have here, you realize your h is just, you can just cancel the h out. So we cancel the h out. So what is finally left over? You're going to have negative 1 left, right? That will be negative 1 over x times x plus h. And then you can bring that, negative 1, the negative sign to the front to just make it a little nicer looking. Then that is your final answer. Okay, that's your final answer. If you want to take a look, in this case, what you can, your denominator cannot be 0. So we know x cannot be 0. And then you have to go look at here, right? X cannot be 0 either. And then look right here. Then we realize another thing is, if we set that cannot be 0, then I'm just going to have x cannot be negative h. Okay, so that is your final answer right there. Alright guys, that is the P6 rational expressions. Okay, make sure you understand. I want you to ask questions. If anytime you have a question, make sure to ask me. I'm always happy to answer your questions. I want to help you. Thank you, and good luck with your homework.